VLSos here. This is a video lesson for pre-algebra, graphing an equation. We're going to give one example. We're going to graph the equation y is equal to negative 2x plus 6. This technique for graphing can be used with any equation. This is a fairly simple one. We're going to go through a three-step process. Step number one is to make what we call a t-table. In that t-table, we choose values for x, and then we use the equation to find y for every value of x. That we chose. That's quite a bit, so let's do that. I'm going to graph this equation, and notice that it has two variables in it, x and y. Pretty typical choices for math and algebra practice. Making a t-table starts with making a chart in the shape of a T, which is why we call it a t-table. And we label the columns that are created in this T, x and y. We've made our t-table. Now we're going to choose values for x. In the x column, I could choose any number I wish, but I'm in the habit of choosing these specific values to start with. Negative 2, 0, 1, and 2. Those are my choices for x. Now I'm going to use the equation to find y for every value of x that I chose. We're going to do that one at a time. The easiest value of x to work with is 0, so I'm going to start with this choice of 0. I'm going to show side work. I'm going to use the equation. I'm going to calculate y when x is 0. So I'll write the equation, y is equal to the negative 2 times my choice for x, this time it's 0, plus 6. So you can see I use parentheses to put the value of x that I'm currently working with into those parentheses, just to be clear where it is and what I'm doing. I'm multiplying the negative 2 and this choice of x of 0. And then I'll add 6. So y is equal to negative 2 times 0 is 0, and then 0 plus 6 means y is equal to 6 when x is equal to 0. So that was one choice for x, and it led me to find the value of y for that choice. I'm now going to work with a new choice of x, a new value. I'm going to think of x as 1. I'll use the equation and do some side work to find the value of y when x is 1. Y is going to be equal to negative 2 times my choice of x, this time 1, plus 6. Now I'm going to do the math. Y will be equal to negative 2 times 1 is negative 2, and then when I add 6, I get 4. So when I chose x to be 1, y is 4. I'm going to use the equation to calculate the y value for a new choice of x. This time I'm going to use the value 2 for x. And I'll do the side work here. Y will be equal to negative 2 times my choice of x, this time is 2, plus 6. Doing the math, y is equal to negative 2 times 2 is negative 4, plus 6, and negative 4 plus 6 is 2. So when my choice for x was 2, my y value was also 2. Working with a new choice for x, my last one, when x is negative 2, I will find y with the equation. Y is equal to negative 2 times my choice of x is -2 plus 6. When I make a choice for x and I use the equation, what I'm doing is I'm substituting the value that I chose in for x. When I substitute -2 in for x, y is -2 times -2 is a +4, and a +4 plus 6 makes 10. So I'll put that y value 10 into my t-table. That was quite a lot of work, but what I have is points that are organized in my t-table. Step number 2 will be the step now to plot points on a graph from the table. The t-table was a way to organize points to graph. And now graphing is fairly simple now that I have the points that I'm going to graph. These points are ordered pair. They are x, y values. When x is -2, y is 10. That's going to have a y value that will be off of my axis. So I won't be plotting that one until later. It's going to be off my graph. If I put some tick marks, label 2, put a y value here at 6, and here at 3 for reference. Now I'm going to think of this 0, 6 as a point to plot. When x is 0, it's on the axis. I don't go right or left. And I'll have y value of 6 at the same time. This is the point up here where x is 0 and y is 6 at the same time. I'm going to plot the point 1, 4. That's an x value of 1. That's here on the x-axis. And at the same time, a y value of 4. So I'm going to go up to where y is equal to 4. Plot the point. I'm going to plot this point at 2, 2. Its coordinates are 2, 2. That means 2 for x and 2 for y. Plots that point there. Now this point here, -10, 2, it was off my graph. Very often when you use a t-table, you'll come up with some numbers that later when you're trying to graph don't quite work because they're too far off. They have values that are too high. That's okay, but if we were to plot this point, we would go -2x, and we'd have to go up 10, there's 5, and we'd be up here into our work. The third and final step is to connect the points. If I know that this is a linear equation, and I expect that the graph must be a line, then I know exactly how to connect these points. They all line up. The entire graph would be a line, and I can show all of the possible solutions, the entire graph of my line, by connecting those points, putting arrowheads on my line to suggest that it keeps going in both directions. Not all equations, of course, have graphs that are lines. Some of these graphs, some of these equations that we will be graphing in the future are going to be curved, and we'll have to know how to connect the points in order to show the curve.